Can you briefly summarize your educational history?
Yes, I'm trained in civil and geological engineering and earned my PhD at Colorado School of Mines.
And can you briefly explain your professional experience?
Yes, I spent time in industry studying hydraulic fracturing and rock physics at Halliburton and New England Research, and then have since moved to academia at UW-Madison, where I study fractures from micro scale all the way up to earthquakes.
And how long have you worked in your field?
About 13 years.
Dr. Hampton, have you ever been in the field for your work?
Yes, I have.
Would you please give us some examples of that field work?
Yes, so instrumenting highway bridges, both large and small bridges, to understand damage within them with fiber optic sensing or accelerometers. Also including things like being on site at drilling and hydraulic fracturing sites.
Do you do any field work now?
Yes, so right now I go to the field for instrumenting bridges and different types of structures, including historic structures, to understand the evolution of damage within them. I also actively go to oil and gas drilling and hydraulic fracturing sites to try to monitor non-destructive testing methods like fiber optic sensing. Also things like going to a recent project where we have a Sanford Underground Research Facility in South Dakota, which is a mine, and the instrument that listens to the blasting as well as other mine operations that are going on. Also doing large-scale centrifuge experiments at the massive facility at Sandia National Labs to study chemical and nuclear explosions.
Dr. Hampton, did you reach an opinion in this matter on potential impacts from blasting?
Yes, I did.
Please briefly summarize that opinion.
The summary would essentially be that blasting induces fractures within rock materials. The properties of the rocks, as well as the natural fractures that exist within the rocks that are ubiquitous in these surface formations, are greatly impactful to the extent at which fractures extend. And my opinion was that no meaningful data was collected to evaluate that fracture extension and connection of natural fractures, and especially in environmentally sensitive areas.
What do you mean by environmentally sensitive areas?
So things like waterways and wetlands and anything else that's identified within the DNR EIS. So my opinion was that the identified risks and risk sites within the EIS were not evaluated in terms of the blasting impacts, and not enough, essentially no meaningful data was collected at the blast sites, or even a risk rank profile of which blast sites would need some metered amount of data collection.
And did you reach an opinion in this matter on the ability to mitigate the risk of those potential impacts?
Yes. Essentially, there's no way to understand where the fractures will extend or how it will impact different blast sites if they're not evaluated against the risks as well as the natural features and properties of the rocks.
In your opinion, does Mr. David Saver's testimony respond to the opinions you reached in this matter?
It does, but it also responds to several mischaracterizations of my opinions.
Can you give an example of where you understand an opinion of yours to have been mischaracterized?
Absolutely. So probably the largest one is where he stated that I advocate for a complete overhaul and change to standard industry practices and standard blasting practices, but that's not at all what I said in my work. I only advocated for traditional engineering design and risk-informed engineering design, where you take into account some information that has been provided to you by things like the EIS, and you evaluate risk and have a metered data collection campaign associated with that risk.
And what data is needed to evaluate potential impacts from blasting?
So the data that would be needed is essentially the environmental impact or the identified risks that the EIS has already provided. But then for blasting, the things that you would want to have are things like natural fracture information, any type of geometry information on natural fractures, rock properties, any hydrologic conditions, and so on.
And is that missing data important?
Yes, yeah, absolutely. So without that data, you can't make any reasonable estimations of fracture extension or fracture connection to natural features.
In your opinion, at what blasting locations should this data be collected for the proposed project?
So this is one of the other probably mischaracterizations of my opinion from Mr. Travis David Saver. He mentioned that I said that all sites and all identified blasting sites need extensive data collection, but that's not true. Following normal standard engineering practices that I teach regularly at UW-Madison, you take informed risk decisions and you rank the sites according to which ones I should look at more than others, and then you have some kind of data collection campaign that is matching that level of risk at certain sites.
And was data collected at those sites?
A minimal amount of data was collected at those sites, things like depth to bedrock, and there was on some surface outcrop areas a mechanical, what was called mechanical testing, which is index testing for surface properties of the rock, but only at surface expressions of those rocks.
In your opinion, do surface measurements provide sufficient information to evaluate potential impacts from blasting in non-environmentally sensitive areas?
So they may be a good way to, surface measurements in non-risky areas may be a good way to infer quite a bit of information. Surface measurements themselves are oftentimes, like the rebound hardness measurements that were measured, are index measurements, which essentially index means that it is not fundamentally physically measuring a parameter, it's correlating to a parameter. It also only measures things at the surface where you're measuring it, nothing about within the rock volume or the fractures within the rock.
Sorry, you mentioned rebound hardness. What is rebound hardness?
Yeah, rebound hardness is, the simplest form is you're interacting with the surface like this table. And one of the methods is like dropping a ball on the surface and it bouncing up, and the height of the bounce related to how much you dropped it, and the mass and the gravity relates to those conditions as well as the surface mechanical conditions. And so many rebound hardness measurements are getting things like hardness, which are correlated to things like elastic modulus or sometimes strength. But they're also loosely correlated because it's only on the surface of the material.
Okay, what is elastic modulus?
Yes, of course. So elastic modulus is a critical rock property as well as a property of anything. Essentially, if you squeeze a material and it deforms, it's going to deform based on the amount of stress that you apply, as well as its physical properties of how it responds to that. So the elastic modulus is essentially the relationship between stress and the amount that it strains.
Do surface measurements provide sufficient information for blasting in environmentally sensitive areas?
No, I mean, what you really need to find in environmentally sensitive areas is understanding where the natural fractures are, maybe some estimation of the properties of those natural fractures as well as the rock properties that's between those natural fractures.
In your opinion, did DNR have information regarding the actual mechanical properties to be blasted?
No, the only mechanical information that was provided was rebound hardness at blasting sites, was rebound hardness at some of the surface segments. There wasn't any other mechanical data, boring logs, or experimental data collected at any of the blasting sites.
Was that data collected at other sites?
Yes, I was, after reviewing all the documents, there was actually a stark difference in the data that was collected at all the HDD sites as well as the potential pump station sites in comparison to the blast sites themselves.
Did you reach an opinion on the adequacy of the information obtained for the HDD sites?
No, I just noted that there was, in contrast between the blast sites and the HDD sites and the pump station sites, there's a stark difference in much more data collected at those two sites compared to blast sites.
Dr. Hampton will display Mr. David Saber's testimony again. Attorney Cordy, could you go to page 14? We'll start line 9. Would you please read lines 9 through 19?
So the question is, were there any additional investigations or information which would have been practicable that would have resulted in DNR concluding that blasting would result in significant impacts? And the answer provided was no. The work done here was customary and reasonable. Sufficient information was gathered along with identification of blasting limits and conditions that would allow DNR to conclude that there would not be significant impacts from blasting. Further performing additional borings or conducting test trenching or definitively determine the extent and quality of the rock would require clearing the right-of-way and significant additional superficial disturbance to get proper and necessary equipment through these areas to gather that information. This approach is not customary and the process is both unnecessary and unreasonable.
Do you have a response to that opinion?
Yes, so there's a wide spectrum of the ways in which you can collect geotechnical data. You can absolutely do things in a targeted manner. In fact, they did do that with the more extensive data collection at the HDD sites and the pump station sites, but did not collect it at all for the blast sites. And the evidence that essentially that contradiction shows that it was kind of a choice rather than in practicality reasons of doing it.
Dr. Hampton, where in the permitting materials is the data you say was collected?
So EIS Appendix O and Appendix P contain the bulk of it, along with the Lake Superior Consulting Report contains some as well.
Do you recognize this document that's been marked for identification as Exhibit 825?
Yes, Appendix P, this is the table of data for the boring results.
Can you review that document?
I did.
Does that document inform your opinion that sufficient data to assess blasting is missing?
Yes, it does.
How so?
So it would be really simple to do this. You can just sort the column of the sites by A to Z and look at just the blasting sites. And you'll see that in the table, after you sort them, the table that contains the blasting data shows the only information is depth to bedrock and then blank cells. And then the rest of the sites like HDD and pump station sites the tables are full of information.
Do you recognize this document marked for identification as Exhibit 824?
Yes, this is EIS Appendix O. It contains the boring logs as well as all the experimental data and geotechnical data that was collected.
Did you review this document?
I did.
And does this document inform your opinion that sufficient data to assess blasting impacts is missing?
Yes, it does.
How so?
So a simple way to go through it would be just going to the first page of every single one of the compiled PDFs, which are all the different geotech reports and boring results. And it shows exactly where that data was for, and they're all for the HDD sites or potential pump station locations. There weren't any sites in that document at all that were evaluated for experimental data or any other type of data for blasting sites.
Dr. Hampton, did Mr. David Saber's pre-filed testimony discuss site-specific blasting plans?
It did.
And what is your understanding of the opinion Mr. David Saber reached with regard to site-specific blasting plans?
So this was another mischaracterization of my report. He stated that I was advocating for site-specific blasting plans at each of the sites to be addressed well beforehand and then become unchanging where they cannot be updated throughout the time of the project, which is not at all what I said. It's also not at all normal engineering practice. You collect some amount of data at risky sites, and there's a spectrum of data collection depending on the level of risk, and then you try as best to be able to make an engineering decision about certain sites, develop as much of a plan as possible, and then you can update that as you see more information and more data come available.
Dr. Hampton, do you have an opinion on whether a blasting plan can be altered based on conditions encountered in the field?
Absolutely. It absolutely can be altered as time goes on. I mean, that's good engineering practice, is to have an understanding of risk, identify measurement campaigns to help alleviate some of those risks, and then update as you acquire more data.
Would you please read just the first sentence of the question starting on line 17?
First sentence of the question is, Professor Hampton contends that DNR should have imposed specific limits on blast parameters like borehole diameter, charge size, etc., other than the ones already identified in the general blasting plan.
Is that an accurate characterization of any opinion you reached in this matter?
No, not at all. I think that this is another large mischaracterization. I was stating and referring to those things being important information to be able to understand blast design. But I never advocate for myself or DNR imposing any different limits, because that wasn't my place to opine on.
Would you please read the first sentence of the question starting on line 7?
Yes, the question says, Professor Hampton notes the lack of information regarding timing blast operations around seasons, rain conditions, freeze-thaw cycles, and storm events.
And is that an accurate characterization of any opinion you reached?
No, it isn't. I never stated anything about needing to have blast designs be accounting for seasonal timings. Perhaps they misunderstood the sections that I was talking about in my report that said that seasonal hydrologic changes impact the environment and the ground in which you're looking at. So for instance, slope stability. Stability of a slope changes throughout the year as a function of the seasonal conditions. More rain, less rain, drier, wetter. I never said blasting plans or anything needs to account for when they occur according to seasons.
And Dr. Hampton, did you reach an opinion in this matter regarding fracturing caused by blasting beyond the construction right-of-way?
No, I was never concerned with induced fractures within the subsurface beyond the right-of-way.
Do you recognize these photos that have been marked for identification as Exhibit 382?
Yes, that was provided by Mr. David Saber on the test, or simulated blast is the term that we use, or the test blast that was conducted in the nearby area.
Would you please briefly describe the simulated blast?
Yes, Mr. David Saber mentioned conducting a test blast in a nearby area where they set off a charge underneath the surface and then used an excavator to try to excavate as much of the fractured rock and rubble as possible, and then used that to conclude that all of the fractures and induced fractures were within the excavation zone.
Dr. Hampton, are you able to make any observations based on this photo?
Yes, from just glancing at the photo, you can see that there's complicated rock structure on the right-hand side of it. You could see different kind of planar features within the rock where it looks like some things have failed or been removed based on those planar features. That is indicative of of natural fractures and joints and complicated rock structure near surface, which makes sense, and near surface rocks that have been weathered. And these fractures are, you can't tell beyond this image what they look like in the subsurface or how they extend beyond, or if the blast has extended them further.
Does the simulated blast and Mr. David Saber's discussion of it alter your opinion in any way?
No, and it reinforces some fundamental differences in understanding of where damage zone is versus excavation zone.
Would you describe what you understand those differences to be in further detail?
Yes. So there's a misunderstanding of between multiple parties of understanding what the word damage zone means. Essentially, when a blast occurs, it has fractures that are generated, and those fractures extend at different distances. And then there's also an excavation zone, and the fractures extend beyond the excavation zone. This is a part of literature for decades. And the excavation zone is where the bucket can essentially pierce the rock. Mr. David Saber's discussions are concerned with the fracture and rubbleized zone, and what he calls this damage zone is essentially, in all of his documents, that excavation zone, saying we were able to collect all the damage zone from this excavation. But I was concerned with the fractures that are actually extended beyond the excavation zone, and also the natural fractures and features that extend and connect with one another. So the fundamental definition of damage is this degradation of physical properties, and that occurs due to fracturing or other types of processes. And there's a difference between what they consider damage zone versus what the real damage zone actually is.
Would you read lines 11 through 13?
The lines state, I have also reviewed another paper entitled Practical Assessment of Rock Damage Due to Blasting by Silva, Worsey, and Lusk, as published in the International Journal of Mining, Science, and Technology, Volume 29, Issue 3, dated March 29, pages 379 385.
And did you review that paper?
Yes, it did. I also reviewed all of the highly cited articles that have cited that paper since, as well as the fundamental study that that article is based upon, which is the 1974 Siskin report.
And did your review of the Silver paper or any of the reports that you just mentioned alter the opinions you reached in this matter?
They do not.
Do you have any opinions about the Silver paper itself?
So there's two main points for the Silva paper usage by Mr. David Saber, as well as the Silver paper itself, that reinforce my opinions.
So what is you said 2 points. What's the first point?
So the first one is essentially that the paper was used as an argument against my numerical modeling that I provided in the expert report on blasting. The argument was that all modeling, not numerical modeling, all modeling overestimates damage. And so reviewing that report, that paper did a review of what's called empirical analytical models. They're not finite discrete element physics informed models. They're essentially correlated models based on peak particle velocity and other geophysical parameters. It reviewed those types of analytical models and stated that and then also provided one themselves and stated that they did not match really well with the Siskin report from 1974. But my model was physics informed finite discrete element method that is a commercial software that uses blast physics with the detonation wave and the gas pressure wave, as well as rock properties and fracture properties and all those things. It's not a analytical correlation model that is based off of geophysical measurement of the surface.
And what was your second point regarding the Silva study?
So the second point was the Silva study actually misunderstands the 1974 Siskind report that it is fundamentally based on and uses for validation of its work. So essentially the Siskind report is about a test blast. There's a big rock wall and there's a blast in this rock, and then they took cores out of the rock wall and they tried to understand damage within the cores that they took out at different distances away from the blast. And so if you can imagine a spider web, a dense spider web at the center and it getting less dense as it goes out, of the fractures that are induced from the blast, if you take core out, you're studying two different things. One is the small scale microcrack damage, and two, you're missing all those big fractures. You're not sampling them. And so, yeah, it misunderstands that. It uses the microcrack damage as an estimation of this rubbleized rock fracture damage zone, which are damaged at two fundamentally different scales.
Dr. Hampton, I saw a whole lot of movement with your hand. Would illustrating your answer allow you to better respond to that question?
Yes, yeah, it would be easier if I could draw it on a whiteboard or just say.
Judge, can I approach the witness and hand them a blank piece of paper and some writing utensils?
So essentially, the Siskind report has a rock wall, and we'll pretend that the rock wall is just this flat wall that we can see. It's the side of the rock wall. There's a blast. There's a charge that's placed, and there's a whole bunch of fractures that are generated within the zone near this charge. And then I'm going to circle kind of like what an excavation zone would be a zone inside of that fractured area that is able to be excavated. Within all different geologic materials, especially geologic materials at in the subsurface, or especially in near surface conditions like this, there's these things called natural fractures and natural features in structure, like these red lines. When you blast, you induced fractures near the blast, as well as the physics of the detonation wave and the gas pressure wave can actually cause to extend and alter some of these fractures that are at distance away from your actual damage zone. And so that's for several reasons, but also the Siskind report was studying, I'm going to draw a couple of circles here. There's circles close and within kind of damaged areas, and as you get further away, those are the cores that were taken out of this rock face. And so they studied little wave velocities, ultrasonic wave velocities within the cores themselves, diametrically across the cores. And so that essentially studies microcracking at the scale of the core within that. That's what ultrasonic velocity waves are sensitive to. They're not sensitive, and the cores are not sampling these things over there or these bigger fractures. They're just not fundamentally sampling. The Siskind report was studying microcrack damage as you move away from it. The Silva paper misunderstood and mischaracterized that information as trying to capture this region here, which is essentially the excavated zone where the macro fractures are dense and it's rubble. And so it uses the microcrack data to inform where these macro fractures are, which is just a misunderstanding of that report that it's fundamentally based on, that it uses for validation.
Dr. Hampton, did you reach an opinion in this matter regarding slope stability?
Yes, I did.
And what is that opinion?
Essentially that the impacts from blasting and construction activities were not fully assessed in terms of slope stability. The data that was collected for slopes was essentially just slope grade, which is just another word for slope angle. And the stability of a natural slope or a man-made slope is governed by many more things other than just the slope grade.
Would you please read lines 24 through 27 and lines 1 through 3 on the following page, ending with that.
So the question is, what is your opinion on Professor Hampton's stated need for DNR to have site-specific information and slope stability information such as soil composition and layers and soil saturation when assessing blasting impacts? The answer that was provided was, I disagree. Site-specific slope stability information such as the precise delineation of soil layers and saturation data are not required to evaluate blasting impacts. Requiring this kind of information is academic and inappropriately assumes slope failure without acknowledging how a blaster will mitigate impacts on site.
Do you have a response to that opinion?
Yes, a couple. There's no way to assess slope stability without information regarding the slope or the loading in which that is occurring. Also, slopes can fail from a multitude of things, not just the dynamic waves from blasting, but also from removal of material at the toe of the slope or construction in the slope, or removal of vegetation and soil materials from the slope. All of those things impact slope stability. And the inappropriately assumed slope failure part is confusing because slope stability doesn't assume slope failure, it's just assessing the stability of a slope.
Dr. Hampton, would you read lines 9 through 13, starting with the first full sentence on line 9?
Yes, it says, finally, the self-imposed limit of 12 inch per second PPV at the construction right-of-way edge and my witnessing of a simulated test blast resulting in nominally 2 inches per second at a distance of 50 feet simply implies that the probability of inducing a slope failure of a natural slope is quite unlikely, and that any attempt to investigate the slope would likely cause more significant impact than the actual blasting.
Do you agree with Mr. David Saver's opinion on what that simulated blast implies?
No, I don't.
Why not?
So the main reason is slope failure can be caused by a number of things, including the dynamic waves that are emanating from a blast, but also includes significant things like construction through the slope, and that the PPV limits and things of the simulated blast are data collected at the test blast site, but they weren't compared to any particular slope. So it's hard for me to understand why it would be unlikely for that test blast to show that no slope could fail when it wasn't actually compared to any slope, a steep slope, a shallow slope, any features of a slope whatsoever.
Okay, what is peak particle velocity, or PPV?
So peak particle velocity, or PPV, is essentially a geophysical measurement using things like a geophone or a fiber optic cable, where it looks at ground deformations and the velocity of those ground deformations. And so it captures that deformation as a function of time. And so peak particle velocity takes that seismic record that is this waveform of the ground motion, and it picks the peak value of that velocity. So it's saying that essentially, just like if you drive a car multiple speeds on a highway, it's going to pick the top speed. That's your peak particle velocity.
That vibration, that peak particle velocity measures, is that the only factor that impacts slope stability?
No, not at all. So there's a lot of things that impact slope stability, including geometrical properties of the slope, what angles it is, where the layers are, the geotechnical properties, the hydrogeological information, so whether or not there's water there or not, where the water table is. And then also another thing that impacts the stability of slope are the dynamic things, like the dynamic wave that can be characterized by a peak particle velocity moving through a slope.
Is vibration intensity from a blast the only factor that impacts damage caused by blasts in general?
No, so this is also reaches back to that Silva paper that uses peak particle velocity to build models. The reason peak particle velocity is used in a lot of these things is because it's easy to measure. There's nothing wrong with that. It's a geophysical measurement, has peak particle velocity. It can tell you some information about what's going on. But the peak particle velocity that's measured, that's not a direct assessment of how fractures extend and grow. The measures of that are understanding the detonation wave and the gas pressure wave, as well as the properties of the fractures themselves.
And Dr. Hampton, did you model potential blasting impacts as part of your work on this case?
I did.
Would you please briefly describe your model?
Yes, so I used a commercially available finite discrete element method software that you can input rock data like mechanical properties as well as fracture information like natural fractures. And then you can also input things like real detonation wave and gas pressure waves from real blasting. And then I use that information to study the impact of variable rock properties on the extent of blasting and the connection of fractures. This was meant as an illustrative case. I didn't model a particular blast site because, again, there wasn't any data for me to actually do that at any of the blast sites. But what I did do was just look at the literature and the rock properties from HDD sites to create an illustrative example of how fractures extend and connect within the subsurface and what they're a function of.
So did you make any observation from modeling potential impacts?
Yes, the main observation is essentially that small changes in properties like mechanical properties or the natural fractures and their geometry and their properties within the subsurface significantly impact how much the fractures extend or connect to other natural fractures and have those extend as well.
Dr. Hampton, did your model take practical blasting considerations into account?
Yes, so it modeled the detonation wave and the gas pressure wave, standard rock properties, mechanical properties, fracture information, as well as things like the hole geometry, charge length, charge density, velocity of detonation, all the parameters associated with the charge itself as well.
Does your model account for differences in explosive agents?
Yes, it easily accounts for that, and I looked at that as well, where you can change the density of the charge, the velocity of detonation, so those are the features of the charge. You can also change and adjust the time history of the detonation wave, and then the following gas pressure wave as well. So those are all practical features of a blast.
And does your model fail to take into account any other practical blasting considerations?
No, the only thing that should be said is that it is an illustrative model. If we wanted to model at one of the particular sites, then we would need some of the data collected at those particular sites to study that site in particular.
Does the simulated blast you previously discussed alter your observations from your model?
No, the simulated blast that Mr. David Saber provided in his documents does not alter my opinions. It just reinforces the fundamental difference in understanding of excavation zone versus damage zone, where the fractures can extend outside of that.
Dr. Hampton, do you recognize these photos?
Yes.
And what are these photos?
Essentially the photos along some of the blasting route.
No further questions.
I have a clarification or a couple questions to try to clarify something. You gave some testimony about your modeling, which was, you said, software-based, right, a model, and then testifying about the simulated test blast. There was some testimony, written testimony from Mr. David Saber, right?
Yep.
Is the simulated test blast a simulation, or was it an actual blast?
Good question. So the terminology is funky there. That was just a blast that was done in the field. You can just call it a test blast. It's called a simulated blast sometimes, I guess. But that's just a blast in the field. That's not modeling or analysis or anything like that.